Let's do a review of factoring. So everything I'm going to go over, you should have learned in grade 10. We're going to start off with common factoring. And here are the steps to common factoring before we go through some examples. You want to determine the greatest common factor, also called the GCF, of all terms. You want to divide out the GCF of all terms. And then you want to write the GCF in front of a set of brackets and leave the remainders inside. So all of these steps will make a little bit more sense as we are going through our examples. So example 1, we have 4x squared minus 12x. So our polynomial that we're going to factor has two terms. Now we want to find the greatest common factor of each term. So we're going to start off by looking at just the coefficients of our terms. So by that I mean the 4 and the 12. And what I like to do is do a list of all the pairs of numbers that multiply to give me that coefficient. So 1 times 4 gives us 4, and 2 times 2 gives us 4. Now for 12, I have 1 times 12 that gives me 12, 2 times 6 gives me 12, and 3 times 4 gives me 12. You can do this in your head, or you can use your calculator for this. I then look at all of my factors, because that's what I have right in front of me. These are all factors, and I find the largest that is common between the two. And in this case, it is the 4. So if we're just looking at the coefficient part of the terms, 4 is the greatest common factor. Now we need to look at the variable part of the terms. And we're going to look at x, and we're going to look at, we're going to look at x squared first, and we're going to look at x. So what we want to do is similar to what we did with the numbers, and we want to break this down a bit. Now x squared is just x times x. And when we have x, we literally just have x. So what is the most that they have in common? Well, they each have at least one x. So our greatest common factor is going to be 4x. So now I'm going to get back to where my polynomial is, and I'm going to go to kind of step 2. So we've done the first one, we've determined the greatest common factor. Now we want to divide out the greatest common factor of all terms. And we're going to do that in one sec. I am going to write the greatest common factor outside a set of brackets. So 4x, and then we have a set of brackets. Now in the brackets, we put the remainders, because what we're doing is we are dividing 4x squared by 4x. And that leaves us with x. So that's our remainder. So we're going to put that in the brackets. And then we are dividing negative 12x by 4x. And that is going to leave us with negative 3x. So our final answer is 4x times x minus, not 3x, sorry. That is a little bit of an error, just 3. Let's fix that up. We'll make it look nice. Goodness, okay. Here we go. Okay, so our final answer is 4x times x minus 3. Let us do another example. So our second example, we have negative 3x squared y cubed plus 15x y squared minus 12x. So I'm not going to write out my big number list and my variable list looking for the greatest common factor. I'm hoping most of you can just do it by inspection, which you're just kind of looking at it and thinking in your head. Now, our coefficients are negative 3, positive 15, and negative 12. And each of these can be divided by -3. And so -3 is actually the number part of our greatest common factor. And then we're going to go and look at our variables. And we have an x squared in the first term, an x in the second term, and an x in the third term. So the most x's that we have is just 1. And now we're going to go to our next variable. So our first term has y cubed, then we have y squared, and then we don't have any y's at all. So we can't factor out a y. So our greatest common factor is -3x. And now we're going to write the remainders in our brackets. So -3x squared y cubed divided by -3x leaves us with x times y cubed. Then we have positive 15x y squared. Divide that by -3x. We end up with -5y squared. And -12x divided by -3x leaves us with positive 4. And that is our final answer. Let's go on and take a look at difference of squares factoring. So difference of squares factoring follows a specific pattern. So look for the pattern that follows. So a squared minus b squared is equal to a plus b times a minus b. So what we want to do is we want to look for polynomials where we can write them, or maybe they're already written, as something squared minus something squared. So our first example, but we'll call it 3 because we're continuing on, is x squared minus 25. Now we have x squared, and 25 isn't squared, but we can write 25 as 5 squared because they are equivalent. So now we have something squared minus something squared. And we're going to treat our x as our a and our 5 as our b. And to factor that, we end up with x plus 5 times x minus 5. Now, to do difference of squares factoring, we need to make sure that we have a negative between our two terms. Or a subtraction sign. And both terms, I already said this, must be able to be written as something squared. So as a squared term. Okay, I'm going to put term there because we could have a number, we could have a variable, we could have a combination. Let's do one more. So example 4, we have 4x squared minus 1. Now here, we can rewrite 4x squared as 2 times x and then all of that squared. And those two things are equivalent. And we have 1. We can write that as 1 squared because 1 squared is just 1 times 1, which still just gives us back 1. So let's write that at the side here. So 1 can always be written as 1 squared. Okay, so because 1 squared is equal to 1 times 1, which still just gives us 1. We could also just write 1 as like 1 to the power of 4, because that will give us 1 times 1 times 1 times 1, which still just gives us back 1. And I'm going to put etc. here because we can continue on in this vein. Now let's get back to our example 4. So in example 4, our 2x is the same as our a, and our 1 is the same as our b. So we have 2x plus 1 times 2x minus 1. So we really are looking to follow that pattern that is highlighted in yellow. One last difference of squares example. Negative 2 x squared plus 98. Now, whenever we are doing factoring, we always want to make sure that we are checking for common factoring first. And this is a really good case because at first inspection, it does not look like a difference of squares question, right? We don't have a subtraction or negative sign between the two terms. We have a positive sign. And many of you will look at this and think, well, I can't write negative 2x squared as one whole term squared. And same with 98. So we are going to common factor out a negative 2. And we'll be left with x squared minus 49. And 49 can be written as 7 squared. So we have negative 2, and then in brackets we have something squared minus something squared, so we can apply our difference of squares pattern. So we end up with negative 2 times x plus 7 times x minus 7. Now, I'm going to skip straight to complex trinomial factoring. And this is because you can do it the same as simple trinomial factoring. And actually I'm going to contradict myself and I'm going to go back. Let's do a simple trinomial factoring. We'll just do one. But I'm going to write that we can still do this the same as complex trinomial factoring. So note, can do the same. As complex trinomial factoring. Okay, so with simple trinomial factoring, we are looking at a trinomial that looks like this. We have a x squared plus bx plus c, and we have a is equal to 1. So what we actually have is x squared plus bx plus c. And you'll see when we do complex trinomial factoring, we have the case where a does not equal 1, and then it becomes a little bit more complex. So I think we are on example 6 right now. And we're going to work through this example, and then along the side, I'm going to write down what we're doing and some of the rules. So let's say that we have x squared plus 7x plus 12. Now in our example here, b, if we look back at our pattern here, so b is equal to 7 and c is equal to 12. So this is what we want to do. We want to find two numbers that add or sum to positive 7, which is b. So let's put to b, and multiply. And when we multiply, we get a product to c. Now I'm putting sum and product here because if you go to look for other resources online, this is the terminology that is used by many people, sum and product. So we want to find two numbers that add to B and that multiply to C. So they have to be the same pair. So what I do is I take my C value. So C is equal to 12. And underneath 12, I then write all of the pairs of numbers that multiply together to give me 12. So 1 times 12 gives me 12, 2 times 6 gives me 12, and 3 times 4 gives me 12. Right? Because we're looking for two numbers. Now I'm going to go through this list and I'm going to see which one out of my list, which pair also adds to give me 7. And it's going to be this pair at the bottom, 3 and 4, right? 3 plus 4 is equal to 7. So now I have found my two numbers that I needed. And this is how we are going to use them. So once I've identified B and C, and I've used those B and C to find my two numbers, I am going to write down two sets of brackets multiplied together. And I'm going to put X, or whatever variable I'm working with, at the front of the bracket. And at the back of the bracket, I'm going to put my two numbers. Now both my numbers are positive. That's why I have X plus 3 times X plus 4. And so what we've done is we've taken our trinomial from three separate terms, and now it is all factored together. It is all multiplied together. So when A is equal to 1 and we have a simple trinomial, this is kind of a shortcut or a quick way of doing it. Now we're going to look at complex trinomials, and you can still use the same strategy with complex trinomials as you do with simple trinomials, but not the other way around. So I'll show you what I mean. So factoring complex trinomials. And what we mean by a complex trinomial is where we have ax squared plus bx plus c, and a is not equal to 1. So let us work through some examples, but just before we do that, I'm going to write down the rules. And these are going to be similar to what we just went over with simple trinomials. Must find two numbers that add to B, so whatever that coefficient is of the bx term, and multiply to a times c. So this is where it's a bit different than these simple trinomials. And then what we're going to do is use these terms to split up our bx term, and then we're going to factor by grouping. So lots of things going on here. And there are many different ways to do the factoring of complex trinomials. This is typically called the decomposition method. And it's called that because we are breaking up that bx term. So let's work through some examples. So example 7, we have 6x squared plus 7x plus 2. So let's identify all of our different parts. So A is equal to 6, B is equal to 7, and C is equal to 2. Now A times C is equal to 6 times 2, which gives us 12. So we are going to do our list of numbers, or pairs of numbers that multiply together to give us 12, and we should know it by now. Now, we have found all of those pairs. Now we need to find which pair also adds to give us b, which is 7. So again, we have 3 and 4. They multiply to 12, which is a times c, and they add to give us 7. There we go. 3 plus 4 is equal to 7. So we are going to use those two terms to break up the middle term. So let's rewrite this. So we now have 6x squared, and instead of plus 7x, we now have plus 3x plus 4x. And it doesn't matter which order you put them in. You could have put the 4x before the 3x, that's fine, as long as you have the correct sign in front, and they're both positive in this case. Now what we're going to do is we are going to factor by grouping. So we're going to look at our first pair of terms, so 6x squared plus 3x, and then we're going to look at our second pair of terms, 4x plus 2x, and we're going to factor each of those pairs. So from 6x squared and 3x, we can common factor out a 3x, and we're left with 2x plus 1. From our second pair, we have 4x and 2. We can factor out a positive 2, and we are left with 2x plus 1. Now notice that what we have in the brackets is identical, and that is the way we want it. If you get to a point where what you have in the brackets, and what I mean is this 2x plus 1, if this is not identical, then you've done something wrong and you need to go back. So now we basically have these two giant terms separated by a plus sign. And we can now factor from those terms. So we are going to common factor out 2x plus 1. So we've common factored that out of both of them. And then we are going to be left with 3x plus 2, because those are our remainders or the leftovers. And we are finished. So this is our final answer. We are all factored. Okay, let's do one more. We have 6x squared minus 5x minus 4. So we are going to start off by identifying a, b, and c. So a is equal to 6, b is equal to negative 5, and c is equal to negative 4. We want to, we want to look at a times c. So that is 6 times negative 4, and that's going to give us negative 24. Now we are going to build our list of pairs under negative 24. And I am going to leave out the negative sign for now. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So right now, all these pairs are only giving us positive 24, but we're going to play around with that negative sign, because we know in order for us to get negative 24, then one number out of the pair needs to be a negative, because a negative times the positive gives us a negative. Now let's recall, or actually just highlight, because it's right there, that b is equal to negative 5. So what we need to do is we need to play around with our pairs and see which pair could give us negative 24 and negative 5. So for example, if I decided to do like negative 1 times 24, that would give me negative 24. But then if I added them together, so negative 1 plus 24, that gives me 23, not negative 5. And I need negative 5. And then you could play around with it the other way and say, well, positive 1 times negative 24, okay, that'll give me negative 24. But positive 1 plus negative 24 gives me negative 23, and so on. So you have to go through your list, whether you're doing it all in your calculator or in your head. And where you should land is with 3 and then negative 8. Because 3 times negative 8 gives us negative 24. And 3 plus negative 8 gives us negative 5. So we have found our pair of numbers, and we are going to split up that middle term. So we have 6x squared plus 3x minus 8x minus 4. So again, it doesn't matter what order your two middle terms are in. We could write the negative 8x first and then the plus 3x. The order does not matter as long as the sign is with it. So now we are going to factor by grouping. So our first group, or our first pair, we can factor out a 3x. Then we'll be left with 2x plus 1. And in our second pair, we have a negative 8x and a negative 4. So we're going to factor out a negative 4. And we'll be left with 2x plus 1. Similar to our question up above. And now, notice that we have two big terms, and each of those bigger terms has a 2x plus 1. So we can common factor out the 2x plus 1. And then we'll be left with 3x minus 4. And we are all finished. This is our final answer.